And you say to deal with this, it says when x is 0.5, what is y? And they give us the function y is 3x plus 1 over x. So put in x as 0.5 in here and look what you get for y. All right, so put in x as 3 times 0.5. 0.5 is a half. So 3 times a half plus 1 over half. All right, put that in a calculator and tell me what you get. When you work that out, you're going to get, I'll put it in my calculator, 3 times a half plus 1 over a half. I get 3.5. So I get 3.5. And then plug in when x is 2. I'm going to get 3 times 2 plus 1 over 2, which is 6.5. This is 6.5. 6.5. So that complete the table. That takes care of part I. It says on the diagram now, plot the missing points and plot a smooth curve. So 3.5 and 6.5, those are the missing values. 3.5, so we're going to put in when x is 3.5. When x is a half, this is 0.2, 0.4. So 0.5 would be here. This would be x being 0.5. And what was the y value again? 0.5, y is 3.5. So we're going to plot 3.5. All right, so 3.5 is going to be, this is 3, this is 3.5. So that's right here. Just follow the pattern and put a x, please. So this is 3.5 right here. The next thing we want to do is put in when x is when x is 2, we get 6.5. When x is 2, we get 6.5. When x is 2, we're getting 6.5. 6.5. Oh, good. Then I'm set to plot a smooth curve. So you're going to connect these 2 points. It's a plot a smooth curve, so let's connect them. Let's connect them. This is a weird looking curve. It's almost going to look like a quadratic. Just use a different color. Let's use blue. Swoops through this point, pass through this point, to this point, through this point, through this point, through this point. That's it, something like that. Make sure it passed through all the points. I just wasn't so accurate. Let me try to be a little more accurate. Make sure everything passed through the points. Yep. And that's what you're supposed to have. Now, what are they going to ask us now? I bet they're going to ask something like minimum value and some stuff like that. It says now, by drawing an appropriate straight line on the diagram, find the approximate solution of the equation 3x plus 1 over x equals 6. So this graph represents y equals 3x plus 1 over x. And then now we want when it's equal to 6. So what you're going to do is you're going to draw the line y equals 6. The line y equals 6 is this. This is let me use a different color. The line y equals 6. This is the line y equals 6. remember, my sketch wasn't so accurate, all right? So I am thinking that the correct answers are this point right here and this point right here. So this is when x is, the correct solution that we're getting is when x equal, it look like 0.2, and when x equal 1.8. So the solutions are, just to go around here, the solutions are x equals 0.2 and x equal 1.8 from the graph. All right, so all we did was draw the line y equals 6 and equate it to the curve 3x plus 1 over x. Where the two of them meet, where the curve meet the line y equals 6, that's the point of intersection that gives us the solution, the x values. Always test the answer to see if you're right. Put in x equals 0.2. So 3 times 0.2 plus 1 over 0.2. You get 5.6. So 0.2 not necessarily right. Put in x equal, oh yes, 0.2 couldn't right now because 0.2 go to 5.6. Let me make a more accurate sketch then with this point. Let me try to draw the sketch better so we get a more accurate answer. Trying to get a more accurate answer. We want it perfect, which it won't be. We want it pass through this. All right, so I'm getting now, this look like 0. What is this? 0.04, 0.08, 0.16. Let's work with 0.16. So from our sketch, x is 0.16. And x equal 1.8. And then check it out, try 1.8. 3 times 1.8 plus 1 over 1.8. Yep, them they well close, so we work with them answer here. All right, nice. Now part B now, it give a velocity time graph, and it says calculate the acceleration in stage B. So this is a velocity time graph, or they call it speed time graph. They want us to calculate the acceleration in stage B. The acceleration in stage B is going to be y2 minus y1 over x2 minus x1. This is y2, y2 is 40, minus y1, y1 is 15, over x2, x2 is 60, minus x1, which is 40. So in stage 2, the acceleration, I'm going to call it the acceleration of stage B. So AB means acceleration of stage B. It's y2, which is 40, minus y1, which is minus 15, over x2. x2 is 60, minus x1, which is 40. And that's the acceleration in stage B. 40 minus 15 over 60 minus 40. So let's go ahead and work that out. 40 minus 15 is 25. 40 minus 15 is 25 over 60 minus 40. 60 minus 40 is 20. And so 25 over 20, that will give us the acceleration in stage B. So the acceleration in stage B is 25 over 20, which you can write as 1.25 meters per second squared. That's a very slow acceleration. This is very slow because, yeah, this must be walking. Is a person walking? Let's read this. This must be very slow. The speed time graph represents, no, this is way too slow. Why would a car be going this slow? Like, this is really slow. Like, the car is taking, if you find the total distance under here, the car is taking 1 minute to cover this distance. Let's work out the distance in our head. It's the area under the graph. Like, this car is really moving very slow. The car covered. That's really slow. That's crazy. That's crazy. Calculate the average speed of the car during stage B. So on the average speed that it travel right here. All right. So average speed is total distance divided by total time. That's how we find average speed. Average speed is total distance divided by total time. So I'm going to call it, for speed, acceleration is A, so speed is V. So I'm going to call it VB. For average speed in stage B, it's equal to total distance over total time. Total distance over total time gives you average speed. Always remember that average speed is total distance over total time. Now, after we write down this now, average speed to be total distance over total time. Now let's go ahead now and work out the average speed. Working out the average speed, we're going to get the average speed is equal to, going around here, average total, the area of this triangle will give us the total distance, and area of the triangle is a half base times height. The base is 20 and the height is 25. All right, and so we're going to say it is a half of base of 20 times a height of 25. And that's of course being divided by the total time being 20. And you might say, so sir, how you get 20 and 25? We get 20 by taking the difference between the two. So go from 40 seconds to 60 seconds, that's a difference of 20 seconds. And to go from 15 meters per second to 40 meters per second, that's a difference of 25. So the height is 25 and the base is 20. Then divided by total time. Now the total time, as we saw, is 20. So that's the average speed. So working that out, that's 0.5 times 20 times 25 divided by 20, which is 12.5 meters per second. 12.5 meters per second. Now, the car is going slow because look at that. In 20 seconds, the car is taking 20 seconds to travel 250 meters. Now, Usain Bolt can run a 200 meter in 19 seconds, and he can run 212 meters in 20 seconds. So if the car is traveling at Usain Bolt's speed, this car is moving slow. We know we hear the songs about faster than car and bike, but it's not necessarily true. It's just, just a testament of how fast it is. But, this car is moving slow. Now, moving on. And that's the love I want us to have for mathematics, to just be picturing what's happening in real life. Just picture it and say, well, this car moves slow, like him now have nowhere to go. This driver. Right? That's how I want us to picture the mathematics and have fun with it. Have lots of fun. Now, at time t equals 60 seconds, it said the car started to slow down with uniform deceleration of 2.5. Deceleration means negative acceleration. So negative 2.5 is the acceleration in the next phase. And it said at 60 seconds, the car decelerates to slow down to 2.5. It says, how long will the car take to come to rest? how long will it take for the velocity to become 0? So remember, acceleration is equal to v minus u over t. All right, so it's equal to v minus u over t. Now the velocity of the car, the initial velocity it's coming down from is 40 meters per second. All right, so this is, the deceleration is from v, the final velocity will be 0, minus u, initial velocity being 40, over time t. All right, and then transpose to make t the subject. So flip it up here, and so t is equal to 40 over 2.5. And that will tell you how long before the car comes to rest. It shouldn't take long because this car is moving slow. 40 over 2.5, which is 16 seconds. You don't need 16 seconds to come to rest, sir. You're not going fast. But he wants to take 16 seconds to come to rest. All right, 16 seconds. All right. So if you were to plot that on the graph, you'd have another 16 seconds before him come to rest. Somewhere at about 76 seconds, which him don't need so much time, but we'll not overly criticize this driver. He's just following the speed limit and he's being a good person.